Okay, so a civil engineer is making a scale model of a highway on ramp. The length of the model is 4 inches. The actual length of the ramp is 500 feet. What is the scale of the model? Okay, so same kind of thing. So we have the model and we have the actual, and it says the model is 4 inches and the actual is 500 feet. Okay, and it says, what's the scale of the model? Inches to feet. So that's 4 inches to 500 feet. And then you always reduce fractions whenever you can. So divide by 4. A lot of your calculators will do this for you automatically. Get 1 over 125. So it's 1 inch per 125 feet. 1 inch per 125 feet. So that's the scale of the model right there. So a scale is a fraction. Scale of the model. It's a fraction that shows how sizes correspond between the model and the actual. So 4 inches on the model, 4 inches on the model is 500 feet on the actual, and then just reduce that fraction, divide top and bottom by 4. And that means every 1 inch on the model corresponds with 125 feet on the actual off-ramp, highway ramp. And then, so that's part A right there. And then part B says how many times as long as the actual on-ramp, as the actual on-ramp is the model. So the model is how much longer than the actual, and then they ask us the other way. So it's kind of confusing. They ask us 2 different ways. So question B says how many times as long as the actual on-ramp is the model. So basically, the model is what? It's 4 inches divided by 500 feet, isn't it? The model has 4 inches for every 500 feet. So now we have to change this. Change to same units, top and bottom. Well, how do I know I'm supposed to do that? Well, that's what it means for something to be however many times as long, right? If I said to you, hey, I've got a stick that is 5 inches. Well, let's say 6. I've got a stick that's 6 inches, and the real stick is the real whatever is 2 feet. What part is that? How many times bigger is that? You would need to say, well, 2 feet is 2 times 12 is 24 inches. And so 6 inches is 1/4 of that. You see, you have to get them in the same units to figure out what part one thing is of another, don't you? To answer the question that they're asking, how many times as long, you've got to get them in the same units. So we go, okay, well, we've already got inches on the top, 4 inches. And then on the bottom, you take the 500 feet times 12 inches in every foot, right? And so that's 4 inches on the top. And then on the bottom, 500 times 12, I think, use your calculator, that's 6,000. 6,000 inches. So the model is 4 inches compared to every 6,000 inches, and then just divide that on your calculator. 4 divided by 6,000. It'll tell you what part the model is. When I do that on my calculator, I get something kind of funny. I don't know if you guys are getting it on your calculator. I get 6.666, blah, 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 7 eventually. And then this E, I get an E minus 4. You might get something like that. Do you know what that, when you get that in your calculator, what that E minus 4 means? It means the decimal needs to go 4 places backwards. In other words, 6, let me write it over here. 6.6667. You've got to take that decimal and go 1, 2, 3, 4, and that brings in 3 zeros. So it's 0.0006667. There it is. I don't know how many decimals they want. That's plenty, I'm sure. 0.000. 3 6s and a 7. Yeah, you probably better use about that many. Does that make sense so far? That's a little tricky, isn't it, for part B there? Do you see that? So I took 4 divided by 6,000. How did I get that? Whenever they ask you how many times bigger the model or the real is, you've got to get them in the same units. If you want to know how much bigger one thing is to another, they've got to be in the same language. They got to be in the same units, don't they? So I've got to take that 500 feet on the bottom and multiply by 12 inches in every foot to get 6,000 inches, and then divide on my calculator. And I get this weird thing on my calculator, E minus 4. That minus 4 means the decimal goes back 4. It's actually scientific notation. You remember back from Math 10A? It means times 10 to the minus 4 power. It means that decimal's got to go back 1, and it's to the edge of the number, and then 2, 3, 4. Those 3 jumps bring in zeros. So 0.0006667, or I think it was 4 6s and a 7, whatever. 6s really go forever. And then the other way, part C, is just the same thing upside down. They say, how many times as long as the model is the ramp? So now they're asking for the actual ramp on this one. They're saying the actual ramp. Well, that's going to be the same thing, just upside down. In other words, it's going to be 6,000. You don't have to redo it. You just flip it upside down, because the actual ramp is 6,000 inches for every 4,000 inches on the model. You just turn the fraction upside down. Now they're saying the ramp is how much bigger. In part B, they were saying the model is how much smaller. It's the same question, just upside down. So if you divide 6,000 by 4, I'm getting 1,500. 1,500, which means the actual ramp is 1,500 times as big as the model. That's what that's saying. So in question B there, we answered the model is that portion of the actual ramp, which turns out to be 1 over 1,500. And then part C, how big's the actual ramp? 1,500 times as big as the model. And so there we go.